Here is given what? Here a Ritsuko is skateboarding down a ramp that is 9 meters long and inclined at an angle 15 degree related to the horizontal. That means 15 degree related to the horizontal. Okay, this angle little bit larger. Let me make it smaller. 15 degree. This is a theta. That theta is the angle of 15 degree. Skateboarding, and the length of this one is how much? 9 meter. That's the length, 9 meter. My picture, I'm bad at drawing the picture. This is what 9 meter means. 9 meter, the length of the ramp. And another thing given was the initial speed at Ritsuko at the top of the ramp. Okay, let me say. Okay, at this top, its velocity. Let me write it as a u. Its velocity at the top was 3.5 meter per second. Okay, that means we can say that its initial speed, let me write it as a u, that is at 3.5 meter per second while the Ritsuko was at the top of the ramp. Now, ignoring the friction, that means there is literally no any friction. We have to assume that there is literally no any friction down the ramp, and we have to find when Ritsuko is doing a skateboarding, she will obviously reach to the bottom from the top. And whenever she reaches to the bottom, let's say here, we have to find what will be its speed here. Let me assume that speed as a final speed.
Yeah.
Let me write that as a final speed. And let me write it as symbol as V. And let me say it as what. I want to find that out. Okay. Now here is a big question. I want to find that out. Now, if we can solve this question in many ways, but I want to make this question as simple as possible. As simple as possible. Now, when the Ritsuko was at the top of the ramp, the energies present at that time is what? The Ritsuko was skateboarding down the ramp, and at the top of the ramp, the Ritsuko was not at rest. She was also skateboarding there, and at that time the velocity was 3.5. That means there we can say there was a presence of some kinetic energy. Let me say that as a kinetic. Okay, let me write symbol as Ke, or we can say energies, or we can sum of energy. Oh, my mistake. I can say sum of energies at the top of ramp should be equal to sum of energies at the bottom of ramp, because we know that energy is neither be created nor be destroyed, but can be transformed from one form to another form. And we know that energy is never lost. I told you, energy is neither lost, neither created. That means whatever the energy that Ritsuko possessed during the skateboarding at the top of the ramp, that energy should be what? Same at the bottom also. So that energy is not lost during this skateboarding, during this whole, we can say during this whole process, or we can say during this whole motion, the energy is not lost. That's what the information we have to make sure. Now another thing we have to know is that when at the top, when the Ritsuko was at the top, there is two forces acting there. Since there was a motion, that is what? There's an initial kinetic energy. Let me write as a K as initial kinetic energy, plus there is another form of energy present there. That is at the top that Ritsuko is present at a height of what? H from the ground. The Ritsuko at the top of the ramp, that the Ritsuko is present at a height of H. If if the person is at certain height, then we can say that there is a presence of what? Potential energy. That means, let me write the another energy present is what? Potential energy as initial potential energy. Other than that, there is no any energy present at the top of the ramp. When the Ritsuko do a skateboarding, and let's say Ritsuko reach to the bottom, that means at bottom there is only a presence of what? Kinetic energy, because she is moving there, but potential energy is zero. Any body to the ground, that has always the potential energy zero with respect to the surface. We know that. Now we know that what is kinetic energy? Kinetic energy half mv square, half mass times the velocity square, but at the top it's u square. Yeah. Potential energy is what? M times z times h, where h is the height from the surface. Kinetic energy is what? Half mv square. Now we know the value of what? We know, okay, one more thing. If now we can take the m common from the left side, we will get half u square plus g h is equal to half b square. Yeah. This m is on all sides, that's why I will take a common of m and just remove it from all sides, cancel that out. Now, one more thing here is, here I got what? Here I got a new thing called h, but in the question, the value of h is not given. For that, we have to do some concept now. We have to do something. Let's recall the knowledge of trigonometry. This is my h. From the trigonometry, we know that my sine theta, my value of sine theta is equal to what? Sine theta is equal to hypotenuse, that is the h, by perpendicular by hypotenuse, that is L, where this L is what? The length. That means your h is equal to what? L sine theta. That means now I can write this h to have this value, L sine theta. I can write it. That means I can write what? Half of u square plus g. Now the value of h is what? L sine theta. I can write that is equal to half b square. Okay, let me now plug all the values. That is equal to half u. What's the value of initial velocity? 3.5 meter per second square. Yeah. Plus the value of g, 9.8. The value of length, that is 9 meter. The value of sine theta, that is sine theta is given 15 degree. That's the value I will get it. Now, whatever the value I get it from here, multiply that value by 2. That is now my v square looks like. Okay, let me put that number in my online calculator. I got 2. Now I got it first. What? Half multiplied by 3.5 square plus 9.8 multiplied by 9 multiplied by sine of 15. I got all of these values. Whatever the value I got here, I got as what? I got my b square to be equal to 2 multiplied by 28.95. I got it. B is equal to now square root of 2 times 28.95. Okay, let me put that value again. 2 multiplied by 28.95. Whenever I do that, I get a value of
7.61.
Yes, the value of the velocity I got is 7.61 meter per second, and that is what. And this is your value, and this is what we call the final speed of the Ritsuko at the bottom of the ramp.
Got it.
That's what my answer will look like. Okay, that's